Hi everyone, it's Coach Fred here, and today we're going to be talking about triangles. Now, a lot of this is review because we've talked about triangles for a long time. But if we were in class, I'd ask you to define a triangle in your own words. And I love that we can break that word down. Tri means three. Angle mean we've created. We know what angles are, so it is a figure. It's a polygon with three angles. But we don't. There's all different types of triangles, and there's lots of ways that we can name them. So we can classify or name a triangle by the number of sides they have. So there are three types of triangles that we name by sides. We've got scalene, we've got isosceles. We've talked a lot about that one. And then the one I told us that we really have to be really careful when we see that word is equilateral. He's the most special. Okay. All right. Well, a scalene triangle has no congruent sides, so no equal sides. It's going to look something like maybe that. Okay. So no equal sides. An isosceles triangle has at least two congruent sides. Now, we've talked about this one a lot. Now, we could draw it like this, and these could be our congruent sides. But you have to be very careful, because what if I draw an isosceles triangle and I make these the two congruent sides? So just be careful of that. And then an equilateral triangle, all sides are congruent. Okay, so those are the three ways we could name a triangle, by its sides. But we could also classify it based on their angles, and sometimes that will happen. So we have three that I'm going to talk about. We have an acute triangle, which means it has three acute angles. Ask yourself, what are acute angles? And I'm going to remind you now that those are angles that are less than 90 degrees. So it has three small angles. We have an obtuse triangle. Which means that it has one obtuse angle. And an obtuse angle is greater than 90 but less than 180. So here you can see the obtuse angle. It's greater than 90 but less than 180. And the reason it can only have one is because the three angles of a triangle can't exceed 180. So it would only be able to have one that's bigger than 90. And then the one we've spent some time talking about is the right triangle. And that would be a triangle that has one right angle. Something like that, okay? So sometimes you're going to be asked to state whether a triangle is acute, right, or obtuse. So I'd ask you, what would you do first? Well, I always, no matter what, if I'm given two angles of a triangle, two angle measures, I'm going to find the third using that triangle sum theorem that we've talked about. We know that the three angles of a triangle add to 180. So I'm going to do that first, and then I'm going to decide. So what should I do first? Find the third angle. That can usually help you do a lot of different things if you find that third angle. All right, to find the third angle, I would do 55 plus 43. If those were the two angles, that's going to give me 98. So then I would do 180 minus 98, which is going to give me, what is that, 82? Yeah, so 82. So I look at the three angles. I don't see an obtuse angle. I don't see a right angle. I see three acute angles. So this would be an acute triangle. All right, 47 and 43. Let's see. I'm going to add 47 and 43. So that gives me 47 plus 43, which gives me, 90 degrees. So I know those add to 90. So I know that the third angle would also then have to be 90. So this would be a right triangle. All right, I'm going to leave that last one for you to try. All right, so now that we know that about a triangle, some other things that seem like we should make sense, but we want to make sure we define, okay? So if I give you a triangle, like that first one, let me draw that first one, 55, 43, and 82. Okay, so I'm going to say this is 82, 55, and 43. Now I'm going to label this triangle A, B, and C. Now notice I used capital letters. Usually in geometry, or when we're talking about figures in math, if we give you capital letters as the vertex of the triangles, then the side opposite that angle, we'd use a lowercase letter. So for example, across from A over here, we would use a lowercase a. Across from C, we'd use a lowercase c, and across from B, we'd use a lowercase b. All right, well, we're going to talk about this and investigate this in class, but the longest side of the triangle has to be across from the largest angle. So in this case, this 82 is the largest angle. So I know that B is the longest side of the triangle. And in the same regard, I know then the smallest angle is C, 43 degrees. So I know that C is going to be the shortest side of the triangle. Shortest and longest. Okay, that's going to be important as we extend our understanding of triangles. All right, I want to take a look at these special triangles we've talked about, the isosceles triangle and the equilateral triangle. So an isosceles triangle, again, has at least two congruent sides. And what we've learned is that in that triangle, the angles opposite those sides, so that's opposite that side, that is opposite side, those two angles are equal, are congruent, okay? That's going to be an important feature for us. Now, there's a couple other things that are really cool about this that we're going to learn when we learn about congruency in triangles. If I have an isosceles triangle and I want to drop an altitude into that triangle. So that means I want to drop a perpendicular segment right from the vertex. What it does to that base is it bisects it. That means it cuts it into two congruent parts, so two equal parts. So that altitude, that height of the triangle, that's the height, it bisects the base. Okay? All right, and that's going to be something that we might be able to use. Now, the one triangle I want us to think a little bit more about is a very specific isosceles triangle. This very specific isosceles triangle has a right angle in it. Okay, and if it's a very specific isosceles triangle, it means these two sides would be equal. All right, so that would be called an isosceles right triangle. An isosceles right triangle. Well, the interesting thing about that is if that's 90, and then these two base angles are equal, because those would be the base angles, the angles opposite the congruent sides, well, they'd have to add to 90 because they have to all add to 180, which would make each one of these 45 degrees. Now, we call it an isosceles right triangle, and even more specifically than that, we're going to call it a 45, 45, 90 triangle. That 45, 45, 90 triangle is going to help us with so many different things that I wanted us to really be specific about it. I want you to take a minute and look at it. A 45, 45, 90 triangle is isosceles and it's right. All right. Equilateral. Equilateral triangle we know has three equal sides, but one of the things we've talked about in class a lot, anytime you see the word equilateral, I want you to right away know that all three angles would be 60 degrees. All three of them, okay? And so that is going to be something that we're going to use a lot. It's going to help us with other figures. Both of these are going to help us determine things about squares and rectangles and hexagons and pentagons. So we really want to feel comfortable with these two triangles, because if I forget everything about other shapes, these two can help me remember it. All right, so now let's practice naming. So I want you to take a second and pause and find the value of x and then give the best name for the triangle, okay? And then answer the questions on the attached multiple choice. Okay, so if you did that, you learned that you would do 100 plus 35, which is 135. You would subtract that from 180, which would give me 45 degrees. Okay, you'd look and see that you have an obtuse angle right here. So x is 45 degrees, so I know that it is an obtuse triangle. But I could also name it based on its sides. And since every angle is different, that means that all three sides of the triangle are different. So I would call this an obtuse scalene triangle. Okay, so I could name it using both the sides and the angles. Okay, over here I already noticed a right triangle. This is 30. I'm going to find the other angle. So 90 minus 30. Why 90 minus 30 and not 90 plus 30 plus x equals 180? Well, because if this is 90, then these two angles together have to equal 90. So I'm just trying to make it easier on myself. So 90 minus 30 gave me 60 degrees. So this would be the best name for this triangle. You might have said was a right triangle. But again, it has three unequal sides, so it would be a right scalene triangle. Okay, go ahead and try the next two. Okay. All right, and then the last one, if we look very carefully at it, we can see that it's got a 45, 45, it's got a right angle and a 45-degree angle, which makes x 45 degrees. Okay, now our best triangle name we just talked about would either be an isosceles right triangle or a 45, 45, 90 triangle. All right, guys, that's it for today. Hopefully that video gave you a little bit of sense of the different names that we have for triangles. We're going to be using that in class tomorrow. Now, I do want you to go on to video number 2. Okay, have a great day.